Hi everybody, welcome back to this course on Internet Technologies. I'm Vardan and today we'll be studying about IP addressing and IP address classes. Let's begin by understanding why we even need IP addresses. Every device connected to a network, whether it is your laptop, phone, or a web server, needs a unique identifier so data can find its way to the right place. That's where IP address comes in. It's a logical address assigned at the internet layer of the TCP/IP stack, and in IPv4, this address is 32 bits long. And an IP address doesn't just identify the device, it also tells us which network the device belongs to. And this is crucial for routers. Without a system like this, the internet wouldn't be able to deliver messages accurately between billions of devices. Now, an IP address is divided into two parts: the network part, which identifies the network, and the host part, which identifies a specific device within that network. Here we have an example of an IP address in its decimal and binary representations. Uh, the number of bits allocated to the network part versus the host part determines how how many networks and how many devices you can have in each networks. The network bits are assigned by a central authority. Uh, the host bits are assigned locally within the organization or the network. Routers only look at the network portion of an IP address when forwarding data, not the host part. And by varying the number of network and host bits, early designers created different IP address classes to suit different sized networks. So, what exactly are these classes? The original IP addressing system was divided into five classes: A, B, C, D, and E. Class A, B, and C were used for unicast addressing, meaning communication from one device to another. Class D was reserved for multicast, where data is sent to a group of devices at once. And Class E was set aside for experimental use. This system is called classful addressing because the address itself indicates its class and how many bits are for network and host. In modern communications, though, we mostly use classless interdomain routing or CIDR, which removes the rigid class structure and allows for more flexible and dynamic IP allocation. But it's still essential to learn the classes for historical understanding. Let's break down Class A addresses. They range from 0.0.0.0 to 127.255.255.255. Here, the first 8 bits are used for the network and remaining 24 bits are for hosts. The first bit is always 0. This way you can also identify that it's a Class A address, and this means that there are 128 possible Class A networks, but each one can have over 16 million hosts. That is 2 raised to the power 24 minus 2, and we are subtracting 2 because one address is reserved for the network itself and one for broadcast. Class A addresses were originally assigned to very large organizations and government networks, but in today's context, that was a massive overkill and contributed to IP wastage, which we'll discuss later. Class B addresses were designed for medium-sized networks. They range from 128.0.0 to 191.255.255.255. In Class B, the first 16 bits identify the network and the remaining 16 bits are for hosts. And here the first two bits are 1 and 0. This gives us 16,384 possible networks, and each network can have up to 65,534 hosts. Again, subtracting two addresses for network and broadcast. Class B was typically assigned to large universities, internet service providers, and sizable companies. It struck a better balance between network and host allocation than Class A, but it still left room for inefficiencies. And Class C addresses were made for small networks, and their range is 192.0.0.0 to 223.255.255.255. Here, the first 24 bits are for the network and only 8 bits are for hosts. Here, the first 3 bits are 1, 1, and 0, and this gives us a huge number of possible networks, over 2 million, but each one can only have 254 hosts. Class C was ideal for small companies, offices, or small subnets within a larger organization. But as the internet grew, this wasn't enough, which is why classless addressing like CIDR became necessary later. Finally, we have Class D and Class E. Class D address range from 224.0.0 to 239.255.255.255 and are reserved for multicast groups, meaning data sent to multiple devices that have subscribed to a multicast group. Class C addresses run from 240.0.0 to 255.255.255.255 and are reserved for experimental or research purposes, and these are not used for normal public networking. Neither Class D nor Class E are used to assign addresses to individual devices. Now, private IP addresses are special ranges reserved for internal network use, and they are not routed on the public internet, which means you can reuse them in multiple private networks without any conflicts. So, Class A private range is from 10.0.0 to 10.255.255.255. Uh, the Class B range is from 172.16.0.0 to 172.31.255.255. The Class C private range is from 192.168.0.0 to 192.168.255.255. Your home Wi-Fi router most likely assigns IPs from 192.168. something dot something, and these ranges help conserve public IP space and secure the internal network. IPv4 also reserves some special addresses for other purposes. So 127.0.0.1 is the famous loopback address, and it's used for testing network software locally on your machine. 0.0.0.0 is a non-routable address representing an unknown or unspecified default target, and 255.255.255.255 is the limited broadcast address sending a message to all hosts within the local network. And finally, a directed broadcast is when you send a message to all devices on a specific remote network and not just a local one. For example, imagine you have a network 192.168.1.0. The directed broadcast address for this network would be 192.168.1.255. If a packet is sent to this address, it gets forwarded through the network infrastructure to all active hosts on that specified network segment. So the problem with the original classful addressing system was massive IP address wastage. Class A addresses, for example, could support over 16 million hosts per network, which no organization actually needed. As a result, most of those addresses went unused. Class B improved things, but still allowed for over 65,000 hosts per network. Again, too large for many organizations. The rigid boundaries between classes caused huge chunks of the available IP space to sit idle, even as demand increased. In fact, 50% of all IPv4 addresses were allocated to Class A alone and 25 to Class B, and this inefficiency and fear of running out of IP addresses led to the adoption of classless interdomain routing in the 1990s and ultimately the development of IPv6. With that, we've come to the end of this lecture, and in the next one, we'll learn about port numbers and connection establishment in client server scenario. Oh, so thank you for joining in, and I'll see you next time.